All right, 9.7 notes, the normal curve and empirical rule on page 15. So we're going to use the properties of a normal curve to find percents. So a normal curve is a bell-shaped graph where the area under that curve is 100%. 50% of the data is below the mean, 50% of the data is above the mean. So it's like our halfway point. So this is what it kind of looks like. Using our empirical rule, it says if you have the mean here, this is the symbol for the population mean. So this is like X bar for everybody instead of just a sample of people. And we're going to use sigma for the standard deviation because, again, that's for the population. So if this is our mean and you add 1 standard deviation, 2 or 3 standard deviations, so this is our symbol for standard deviation of population. And then from our mean, we could subtract 1, 2, and 3 standard deviations below the mean. 68% of the data is going to be within 1 standard deviation from the mean. So below and above the mean, 1 standard deviation, that will have 68% of the data. If you go 2 standard deviations, you're going to have even more data. You're going to have 95% of the data. If you go 3 standard deviations, it's going to have 99.7% of the data. So most people are going to fall within 3 standard deviations of the mean. If it's beyond that, it's going to be considered an outlier. So notice 0.3% is beyond that, and then divide that by 2, right? So we're going to break these apart a little bit more. This is labeled the same. We're going to divide this down the center. Remember, 50% is below the mean, 50% is above the mean. But since this was 68%, 1 standard deviation above and below, we know that these have to add up to 68, so these are both 34%. If you go 2 standard deviations, we know that this is 95%. And if you do 95% minus the 68%, and then divide by 2 equal pieces, you get 13.5%. If you go out 3 standard deviations, again, that was 99.7% minus the 95%, divide by 2, you're going to get 2.35%. And then finally, 100% minus the 99.7%, divide by 2 equal pieces, you get 0.15%. You're not going to have to memorize these numbers because I will show you how to use your calculator to do this in the next lesson. But you do need to know these percentages for today's lesson. So number 1 says 2,000 freshmen at State University took a biology test. The scores were distributed normally with a mean of 70 and a standard deviation of 5. Label the mean and 3 standard deviations from the mean. So the mean is 70 and my standard deviation is 5. So I'm going to add 5, add 5, add 5. And then from the mean, I'm going to subtract 5, subtract 5, subtract 5. And then I can put my percents in order to answer the rest of the questions. So again, this is still going to be 34%, 13.5%, 2.35%, and 0.15%. You don't have to memorize that, but you do need to write it in your picture so you can answer the question. So it says, what percentage of scores are between 65 and 75? So between 65 and 75, then it says 1 standard deviation above and below the mean, it'd be 68%. Between 60 and 80, so 60 to 80, notice that's 2 standard deviations, so that's 95%. And then we have from 60 all the way to 85. So notice that was 95% plus another 2.35%, giving us 97.35%. Part B says, what percentage of scores are less than 55? Well, that would be 0.15%. If it's greater than a score of 80, it'd be 2.35% plus 0.15%. So that's 2.5%. And then part C, approximately how many biology students scored between a 60 and a 70? So the percentage that goes between a 60 and a 70 is adding these two up to get 47.5%. But this is asking how many biology students. Well, if you look up here, we had 2,000 biology students. So we can take this percent as a decimal and multiply it to the 2,000 students, and we get 950 students. Number 2, 500 juniors at Central High School took the ACT last year. The scores were distributed normally with a mean of 24 and a standard deviation of 4. So we're going to label mean of 24. We're going to add 4, add 4, add 4, subtract 4, subtract 4, subtract 4, and then put in our percents. All right, for part A, what percentage of scores are between 20 and 28? You should be getting 68%. Between 16 and 32, you should be getting 95%. That's 2 standard deviations. What percentage of scores are less than 12? You should be getting 0.15%. Greater than a score of 24? You should be getting 50%. That's the mean. Greater than the mean is 50%. Approximately how many juniors scored between 24 and 28? So it's 34% times the 500 juniors. You should be getting 170.